So let's actually take a look at some examples from this paper, the categorization and representations of physics problems by experts and novices. Right, so you can look at how novices actually categorize and represent physics problems, and we can look at how experts do it. And when we say an expert, we're talking about PhD students, and when we say a novice, we're actually talking about first year varsity students. So they do know some physics. They are going to be able to do the basics. And what I want to do is I just want to show you a couple of examples in the paper, not go through the whole 30 pages of this paper itself, because it actually deals with physics, and that's immediately going to cut a whole bunch of us off in terms of understanding it. So the first example, I think, which really helps us to see what's going on, is this one over here, right? Now, what you're going to see firstly is we are, when we're highlighted in green, as you can see, this is diagrams depicted from problems categorized by novices as being in the same groups. And here's their explanations, right? So this is how I would do it, to be honest. As I would look at the problems, what I'd do is I'd look for surface similarities. I go, oh, check this out. They've got something rotational happening here, and it looks like there's something rotational happening there. Therefore, this and this must be similar. And you notice when they're talking about it, they're going, hold on, we're talking about angular velocity, circular things, right? And they do have a language. They do know what's going on. They know it's got to do with rotation. They know it's got to do with angular speed or angular velocities, how things are moving when things rotate. I can kind of get that. That's what I do. But now, here's the second example. I would do exactly the same thing. Like, what's similar here? Well, check it out. You're working with an inclined plane. And look, there's differences over here. On the one, they're trying to work out how the forces work. And on the other side, there's something to do with the way that they could possibly move. But you can see they're dealing with friction, boxes on inclined angles, planes with angles. So they're looking at the surface similarities of what's going on. Now, man, did I laugh when I saw how the experts did it, okay? So here's the experts, and I'm just going to put it in blue. And blow me down. The first thing that happens is this thing over here looks nothing like this thing over here, right? They're completely different. But what they start to do is they go, hold on. The key thing over here is that they're both working with the core law, conservation of energy. So they see deep into it, and they go, these are straightforward problems to do with work energy, okay? Bang, they've got it. And the same thing happens with problem 5 and problem 12. Notice over here, if I saw something like this, I'd be looking for another pulley. They're not looking for another pulley. They immediately recognize that this has got something to do with Newton's second law. Force equals mass times acceleration. Right, so what you can see is, you can see the experts are looking for deep laws. And then they use those laws to explain things. Whereas our wonderful novices are looking for surface similarities, how things actually look the same, and then trying to use that as their guiding point through. So there you can see that you've got novices and experts working in very different ways. Right, so that was the first example I wanted to show to you. But the second example I wanted to talk about was this fantastic thing where they show the different cognitive maps that these different kinds of students have. So sorry that I'm just going through it. You can read it yourself, but I really want to get to the contents of the schematia, and here we go, right? So now, firstly, I want you to see that this is the network representation of a novice. Now, the key thing is, firstly, is that this isn't a stupid oak, okay? This isn't, when you say novice, you're not talking about someone who's got a blank slate. They still have knowledge. They're working in terms of, they know what an inclined plane is. They know what blocks are. They know what length is. They know what forces are. They know what mass is. They know what height is. They do know what conservation is. Friction, they've got no friction. So they're working with a technical language which does have some scientific merit. But you'll see that what they're doing is they're not looking for the big law over here. Here's the law, conservation of energy. That's the law, right? So now if you're an expert, That would be up here somewhere, right at the top. And it would guide how you think about the rest of it, right? So they'd have the law over here. And then once they identify the law, they go, under the law, you do this, and then that, and that. So that's the difference in the way they think. And let's check out if that's actually the case. Okay, so that's a novice. Check out this expert dude, right? As I was trying to explain it to you earlier. Man, oh man, oh man. Right, so now what happens is, the first thing is that they're working with the general set of laws and principles as their top line. The principles of mechanics, well, you've got conservation of energy, and you've got Newton's force laws. And then Newton's force laws work in certain ways, and if this, it's that, if this, it's that. So they've got a set of problem-solving criteria. And that is why these guys love problem-solving. Because they've got their equipment to friggin' solve the problem in the first place, right? Here, over here. If this, then that. If this, then that. And we identify it by firstly getting the general laws. And then therefore, we get to the inclined plane. We know it's a plane. Block surface property. Surface property's got friction. The block's got forces. One of the forces is gravity, and there's other forces. Bang, they can work with the problem and they can solve it. And that gives you two very different ways that experts and novices are working with physics problems. And it's vital for us as a teacher to understand it, because it's going to give us different styles of teaching, different kinds of learners who've got different kinds of expertise.